Hey guys, this is going to be lesson 110, 1.10, the real number. Remember, the same things apply as before. You need to make sure you're writing down everything that I write down. If you need to pause it and ask questions, that's fine. Just pause it, send me a message on Classcraft, or raise your hand and I'll come over to you. Alright, so let's get started. Now, the real numbers are the set of numbers which contain all rational and irrational numbers. That's simple. Now, what are irrational and rational numbers? So irrational numbers are decimals that never terminate. So what that means is they kind of go on forever. They'll go on and on to infinity. But that doesn't mean that they're repeating. Like, repeating decimals go on and on forever, but that's not the same thing. Irrational numbers are decimals that never terminate and have no repetition, meaning they don't repeat. So if you have a decimal that goes on forever, but it's a repeating decimal, then it's not irrational. So examples of irrational numbers would be the square root of 3. If you put the square root of 3 in your calculator, you would get a non-repeating infinite decimal. Now, right here, it says 1.73205. Now, the reason is because my calculator is set up so that it only shows 1, 2, 3, 4, 5 decimals. But this decimal actually keeps going on and on and on, and it doesn't repeat. Another great example of this is pi. Pi is a non-repeating infinite decimal that does not terminate. Same thing for square root of 5, same thing for square root of 41. Now, we don't deal with a lot of irrational numbers yet. We will, but we haven't been. What we've mostly been dealing with are rational numbers. Rational numbers are all fractions or numbers. Notice that fractions is capitalized for a reason. That can be written as a fraction, a over b, where a and b are integers. Remember, what are integers? Integers are all the positive and negative numbers on the number line. So remember, all fractions are numbers, and if you think about what that means, for example, the number 4 is a rational number. It's not a fraction, but it can be written as a fraction of two integers. It can be written as most decimals that can be written as a fraction, where both the numbers are integers. What that means is you don't have a denominator that has a decimal in it. So decimals that terminate, meaning they don't go on infinitely, that terminate, or have a repetition, meaning repeating decimals. You remember that from the lesson with converting decimals, percents, and fractions. There are certain decimals that repeat, and we used to write them like 0.83 with the 3 repeating because it was 0.833333. This is a rational number because the decimal repeats even though it goes on forever. Irrational numbers, remember, there's no repetition. Some examples of rational numbers are 5 over 7. It's a fraction, and both the numerator and the denominator integers. 3, because it can also be written as a fraction of 3 over 1. Negative 1, because negative 1 can also be written as a fraction of negative 1 over 1. 20 over 5, which 20 divided by 5 is 4, and 4 is a rational number because it's an integer. The square root of 16, which is just 4, 0, and 2 square root of 3. Now, like I said, for like 20 over 5 and a square root of 16, if you simplify them, you'll get 4 and 4, and 4 is a rational number. Now, there are different types of rational numbers, so we need to classify them. And we've kind of talked about them a little bit. This might be review from before, but it's really important that you understand how to classify rational numbers. So there are three types of rational numbers. There are integers, whole numbers, and natural numbers. Now these people tend to get these confused. Remember, you're writing down everything I'm writing down in my notes. So three different types of rational numbers. There's integers. Integers, like we said before, the positive, negative numbers on the number line. So things like negative 3, negative 2, negative 1, 0, 1, 2, 3. Notice there's no fractions, there's no decimals in there. Integers are just the positive and negative numbers that are on the number line. Whole numbers are all the positive integers with 0 included. So everything from 0, 1, 2, 3, 4, 5, and continuing on. So whole numbers are all the positive integers plus 0. Are only the positive integer. All the positive integers, 0, no negative integers. Only the positive. So the difference between integers and whole numbers is integers is all the positive and negative numbers on the number line plus 0. Whole numbers is 0 and all the positive numbers only. Natural numbers are all the numbers we count with. So basically 1, 2, 3. It's all the positive integers not including 0. So does not include 0. So think of your natural numbers as the counting numbers. Like when we start counting on our fingers or we start counting something, we start at 1. If you need to put counting numbers down here. Now if you look at the very bottom of your notes, there is a graphic organizer. You will see this graphic organizer again. It will probably show up on a quiz or a test. And if you look at a textbook at the real number section, you'll see this. So this big giant box out here, this big giant box is real number, is all the real numbers. Okay? And remember, if we go up to the top of our paper, real numbers are irrational and rational numbers. So if this entire box includes all the real numbers, this little tiny circle right here is going to be irrational numbers. And this big circle right here is going to be rational numbers. And remember, rational numbers include three different types of rational numbers. And they include integers, not some, but all. Not all, but some are integers, whole numbers, and natural or counting numbers. And you're going to, now this might not seem like a big deal, but you need to understand that whole numbers, integers, natural numbers are all included under the bubble of rational numbers. Now there are some rational numbers that aren't integers, whole numbers, and natural numbers. For example, if we look at 5 over 7, that's not an integer, a whole number, or a natural number. 20 over 5, which simplifies to 4, that is a whole number or natural number. Now, if you go to the next page, you're going to see some of the examples that help with this. Now, negative 47, which is number 1, negative 47. So I can straighten it out here. All right. So number 47, or number 1, I'm sorry, is negative 47. If you read the directions, it says name all sets to which the number belongs. All sets. So the first thing I'm going to say, is this number a rational number? It is. So the first, it's a real number, excuse me, is it a real number? So, is it real? Negative 47 is a real number. It's not a infinite decimal that doesn't repeat. So the first thing I'm going to say is it's a real number. Okay? Now, it's also an integer. Now, after we ask if it's real, the second question we're going to ask, is it rational or irrational? Well, it is a negative number, but it's not a never-ending, non-repetitive decimal. So it is a rational number. Now, if it's a rational number, so if it's rational, is it an integer? Is it a whole number? Is it a natural number? Is this an integer? Yes, it is, because it's on the number line and it's a positive or negative number. So it is an integer. Is it a whole number? Remember, if you look back at your original notes, a whole number is 0 and all the positive integers only, and a natural number is all the positive integers not including 0. So this is a negative number. The only thing it can possibly be is an integer and a rational number. So you're done. I want you to circle number 2 and go to this. Now, for some of these, you're going to need to evaluate them before you can classify them. So for number 3, the absolute value of negative 9 is 9. Is 9 a real number? Yes, it is. That's a real number. Is it rational or irrational? It's rational. Is it an integer? Yes, it is. It's a positive or negative number on the number line, so it is an integer. Is it a whole number? It is a whole number because it is included in the 0 and all positive integers. Is it a natural number? Yes, it is. It's a positive integer, not including 0, so it is a natural number as well. In order to get this question right on a quiz or a test, you would need to have all of that information. I want you to circle number 4 and look at number 5. 1.5625. Now, they would tell us if this was repeating. It doesn't repeat, but it does terminate, meaning that it ends. It doesn't go on forever. So, because it doesn't go on forever, the first thing I'm going to say is it a real number? Yes, it is. We haven't talked about non-real numbers, so we're going to assume that it's a real number. Now, is it a rational or irrational number? It's a non-repeating decimal, but it does terminate, so it has to be rational. It's not an integer because it's a decimal. It's not a whole number because it's a decimal. And it's not an irrational number, so it's a decimal. So these are the only two things that they are. And that's all you're going to put. I want you to circle 0. Set number 6, which is 0. I want you to go to number 7. Now number 7, like I said, sometimes we need to evaluate. The square root of 64 is 8, and that negative sign's out front, so it's going to follow it. Now negative 8 is a real number. It is a rational number. Negative 8 is also an integer, but because it's negative, it cannot be included in the whole number and natural number set. I want you to circle number 8, and I want you to move on down to number 9. Number 9, negative 24 over 6. If I divide 24 by 6, I'm going to get negative 4. Negative 4 is a real number, and just like negative 8, it is a rational number, and it is an integer. Because it's negative, even though it's on the number line, it can only be an integer. It's not a whole number, it's not a natural number. Now look at number 10. What this little sign means, and we've talked about it a little bit, there's a 3 up here. What this means is the cube root of 8. We've talked about the cube roots before. Remember, it's what cube root means, like we talked about perfect cubes. So what number, if you multiply it by itself 3 times, gives you 8? That's what they want to know, and then they want you to classify that. So you need to work on problems 2 through 10 as well. Now, move on down. Go down to this. Now, if you look at this, it's the same like graphic organizer that we had in the very beginning. You're going to see this a lot. You need to